Welcome back. Let's talk about finding formulas for alternating sequences. Before we talk about alternating sequences in general, let's consider this sequence. The sequence 1, minus 1, 1, minus 1, 1, etc. The key observation is that this is a geometric sequence because it has an initial term 1, and then to get from each number to the next, we're basically multiplying by negative 1. 1 times negative 1 is negative 1, and then negative 1 times negative 1 is 1. From the previous video, we know that the formula for this type of sequence is a sub n is equal to 1 times negative 1 to the n. Another way we could write this is using a piecewise function notation, where we say a sub n is equal to 1 when n is even, and negative 1 when n is odd. Now this equivalent definition should make sense because when you have n as an even number, you have an even power of negative 1, which gives you plus 1. And when n is an odd number, you get negative 1 to an odd power, which is negative 1. Similarly, if you had this sequence that started off with negative 1 and alternated negative 1, positive 1, negative 1, positive 1, negative 1, etc., your initial term isn't 1, it's negative 1, and you get this expression. A sub n is equal to negative 1 to the n plus 1. As a consequence, when you have an alternating sequence, first find a formula for the absolute value of the sequence, that's like ignoring the signs, and then multiply the formula by negative 1 to the n or negative 1 to the n plus 1, depending on whether the 0th term is positive or negative. Let's do two examples. The first example is the one we saw before. Negative 2, 3, negative 4, 5, negative 6, etc. We take the absolute value of the terms, and we see this sequence 2, 3, 4, 5, 6, etc. So now that's an arithmetic sequence with initial term 2 and common difference 1. So we get the expression b sub n is equal to 2 plus n. Now to get our original sequence, which is the alternating sequence, we need to multiply by negative 1 to a power. Which is the power we need to multiply by? Well, the 0th term is negative, so we need to multiply by negative 1 to the n plus 1, so that when you plug in n equals 0, you get a negative sign, n equals 1, you get a positive sign, etc. So this expression right here, a sub n is equal to negative 1 to the n plus 1 times 2 plus n. Something that's really useful is you can always check your answer by plugging in values to your formula. So when n is equal to 0, we plug in n equals 0 here. We see we get negative 1 to the 0 plus 1 times 2 plus 0, which is negative 1 times 2, which is negative 2. When we plug in n equals 1, we get negative 1 to the 1 plus 1 times 2 plus 1, which is positive 1 times 3, which is 3. And when we plug in n equals 2, we get negative 1 to the 2 plus 1 times 2 plus 2, which is negative 1 times 4, which is negative 4. And so these are matching the terms of our sequence, which reassures us that we have the correct formula for our sequence. Let's do one more example. Here's a sequence 1/2, negative 2, 8, negative 32, etc. We'll take the absolute value of that sequence. We get 1/2, 2, 8, 32, etc. It's a geometric sequence because to get from 1/2 to 2, we multiply by 4. To get from 2 to 8, we multiply by 4. To get from 8 to 32, we multiply by 4. We can write this as a sequence 1/2 times 4 to the n. Now we need to account for the positive and negative signs. We look and we see that the 0th term is positive, and so what we have to do is we have to take our formula for the absolute value function and multiply by negative 1 to the n. If we simplify this expression, we can see that a sub n can also be written as 1/2 times negative 4 to the n, which is telling us that maybe we could have recognized this sequence as a sequence that starts off with an initial term 1/2, and has a common ratio of -4. Both of those two methods would work. It's up to you which one feels more comfortable to you. Again, we can plug in our values for n is equal to 0 and n equals 1, and we see our values for a0 and a1 do match with our sequence, and we feel comfortable that we have the right formula. All right, thanks for watching. See you next time.